Okay, so get this, right? The Nobel Prize in Physics for 2024, you ready for this? It went to computer scientists.
Yeah.
I know, right? You think like black holes, lasers, all that crazy space stuff?
Yeah.
But no, this year, neural networks. That's where it's at.
And it's not as big of a leap as you might think, really, because this prize, it recognizes how these like computer science rock stars, I mean, they totally flip the script on how we see information, being processed, and not just in our computers and stuff, but like maybe even in our own brains.
Whoa, hold on. Are we talking like computers learning like us? You got to break this down for me.
Oh, absolutely, for sure. Let's rewind. Okay. Back to the 80s, early 80s. Computers then, I mean, compared to now, they were like, basic, like a toaster.
Okay.
But then this guy, John Hopfield, he comes along.
All right. All right. So we got a real pioneer on our hands.
Hmm.
Who was this Hopfield character and what made him such a big deal?
So Hopfield, brilliant physicist, and he starts thinking, right, like, what if we could get computers to, like, function more like brains, Instead of just, like, rigid programming, he used, get this, math to copy how neurons, those tiny cells in our brains, they talk to each other and learn.
So, like, teaching a computer to, I don't know, recognize a cat, but instead of a million pictures, we're talking about, like, replicating how our brains actually do it.
Exactly, exactly. And all this led to something, get this, Hopfield networks. Basic, yeah, but back then, revolutionary. Storing patterns, retrieving them, it's like, a simple version of how we remember things.
That's pretty wild. But, like, every invention, even the good ones, there's got to be room to, like, level up, right? Is that where Geoffrey Hinton comes in?
You got it. Hinton, he takes Hopfield's ideas, right? And he adds this crucial thing, chance, or, as we like to say in science, probabilities. You see, Hopfield's networks, they were like yes or no, black and white. But the world, the real world, it's messy, right?
Okay, wait, hold on. I'm getting a little lost in the technical stuff here. What do you mean probabilities, like, in this whole thing?
All right, imagine this. You're trying to guess, I don't know, what song your friend's thinking of. You wouldn't know for sure, unless, I don't know, you're telepathic or something, but you have, like, make a good guess, right? Based on what music they're into. That's kind of how these networks use probabilities. They deal with, not knowing for sure, and because of that, they actually make better choices.
So it's like Hopfield, he built the foundation, the starting point, and then Hinton came in and was like, okay, but what about the maybes, not just the yeses and nos?
Exactly. This is 1985 now, and Hinton's work on something called Boltzmann machines, it was a game changer, totally. Now we're getting into some serious math, but basically, he found a way to make neural networks learn from the messy stuff, the real-world data, not just, perfectly organized information.
Okay, that sounds like a total breakthrough.
Oh, it absolutely was. I mean, his work, it's the reason we have the powerful AI we see literally everywhere today.
All right, so we went from, like, basic computers to learning like our brains, and suddenly, physics is in the mix. How did neural networks jump from computer science to winning a Nobel Prize in physics? Help me connect the dots here.
Oh, and this is where it gets really, really interesting. So you see, these neural networks, they were born in those early computer labs, but their impact, it's huge, especially in physics. Remember, like a few years back, the whole discovery of gravitational
Oh,
waves?
yeah. How could I forget? Ripples in space-time, the whole shebang.
Right. Turns out those neural networks, they played a key role, like really important in digging through those mountains of data just to find that signal. They're like, superpowered assistants for physicists, analyzing data from telescopes, particle colliders, you name it.
So it's more than just helpful. It's like they're essential.
They're totally essential. Physics these days, it creates so much data. I mean, humans couldn't analyze it all, even if we wanted to. But these neural networks, they help us make sense of it all. This avalanche of data showing us patterns, insights, things we'd never be able to see otherwise. It's like having a magnifying glass, but for like the whole universe.
I gotta admit, that's really cool. But I'm betting not everyone was doing cartwheels when computer guys snagged a physics prize.
Yeah.
There's got to be a story there.
Oh, you better believe it. This prize, it stirred up some serious debate. I mean, the whole scientific community was buzzing.
Yeah, so you've got, like, this traditional view of physics, right? Telescopes, labs, equations scribbled everywhere at that whole image.
Yeah, like Einstein, lost in thought, papers piled up around him.
Yeah, exactly. But then you've got this new wave coming in, computational physics, and their tools are AI, algorithms, all that. So some feathers got ruffled, giving this prize to computer scientists. It's a big change, how we think about it all. Yeah, I can see how that might throw some people off. So where do you stand on this whole thing? Was it the right move?
I don't think it's about right or wrong, you know? This whole debate, it really shows us how science is always changing. Think about the telescope, right? Revolutionized astronomy, but it wouldn't exist without optics, engineering, even glass making.
So it's not about who the tool belongs to. It's about how we use it, what we can learn.
Exactly. And what we've learned from neural networks is huge for physics, no denying that. We're seeing things, patterns, connections, stuff we never could have imagined before. Like, remember those gravitational waves we were talking about? That's a perfect example.
Yeah, so we're not just analyzing data better. It's like changing the whole game, the questions we're asking about the universe.
And this is just the beginning. Imagine using AI to finally understand dark matter, or even, get this, to unlock the secrets of consciousness itself.
Now we're getting really out there. But it's exciting to think about all the possibilities. Yeah. So we've talked a lot about physics, obviously, but I know neural networks, I mean, they're everywhere now. What about the rest of us, the non-physicists? What does this all mean for us?
Oh, that's a great question. So, even if you don't get all the science behind it, neural networks, they're impacting your life every single day in ways you might not even realize. Like, when Spotify recommends music for you, or let's say your doctor uses AI to help with a diagnosis. That's neural networks at work.
Whoa, so this isn't just some abstract concept. It's literally all around us.
It really is. And you don't need to be a computer whiz to appreciate it. But even just understanding the basics of this stuff, it can make you a more informed person, especially in this world that's changing so fast. It's like, learning a new language, one that's becoming more and more important in our tech-driven world.
It's like we don't need to know how an engine works to drive a car, but, a little knowledge can be a good thing.
Exactly. Just like with a car, right? If you learn a little about it, you can make smarter choices.
Right.
Which one to buy, how to take care of it. Same with AI. A little understanding can help you navigate this whole tech world with more confidence. You start seeing the patterns, the good, the bad, and you can actually talk about AI and its role in our society, have real conversations.
That's a great point. Okay, so I think we've established this prize. It wasn't just about two really smart people. It was acknowledging that science itself is changing, how we do it, how we think about it. But it also makes you think maybe we're moving towards like a unification of knowledge. Is that too much? Unification of
Yeah.
that's kind of deep, right? Like,
Yeah.
are we going to start tearing down the walls between like school subjects, no more separate physics, chemistry, all that?
Well, I don't know about all that, but you're onto something, for sure.
Hmm?
For a long time, we've put science into these neat little boxes.
Right.
But the universe, I mean, it doesn't really work like that, does it? We're the ones making those divisions.
So you're saying like at its core, it's all connected. Like something we learned about a black hole could, I don't know, help us understand how our cells work.
It might sound crazy, but yeah, that's the beauty of it. These tools, like neural networks, they're showing us these amazing connections between things that seem totally unrelated. It's like we've been so busy looking at the individual trees, we're finally starting to see the whole forest.
I like that. That's a great way to put it. So what's next then? What happens when we start, breaking down those walls between all these different areas of science?
Who knows? I mean, imagine the discoveries waiting to happen, and maybe we'll use quantum mechanics to, like, create new medical treatments, or use what we know about astrophysics to solve problems here on Earth. The possibilities, they're pretty mind-blowing.
I know it's actually kind of mind-blowing and a little bit, I don't know, humbling. Makes you realize how much we still don't get.
Totally. But it's not about freaking out about what we don't know. It's about, being excited to explore, to dive into the unknown. And honestly, I think that's the biggest takeaway from this whole Nobel Prize thing.
You mean it's not just about looking back at what we've discovered, it's about looking ahead to what's next.
Exactly. It's like a challenge for all of us, scientists, non-scientists, whoever, to stay curious, to question things and never stop asking why.
Mhm.
And hey, maybe someday one of our listeners, they'll be the ones making those big discoveries, blurring the lines, pushing the boundaries of what we know.
And when that day comes, we'll be here, ready to dive deep with them. But for now, that's a wrap on this deep dive into neural networks, Nobel Prizes, and the always exciting world of science. Keep those brains buzzing, everyone, and we'll catch you next time on The Deep Dive.